They brought in the first computers, and everybody working there was super nervous. And they set the computers down. I was like, oh, this is the best thing ever. I really enjoyed using the computers to make digital art.
The creative process, as you know,
Yep.
thrives on limitations, on restrictions. If the brief is do whatever, do anything, it doesn't help the creative process.
They realized that if they were going to make a feature film, it would cost them billions and billions and billions of dollars. And those computers would be obsolete like in a couple years. They used Moore's law to figure out when computers would be powerful enough to render a feature film, and they were like, oh, in about 10 years. And to Steve Jobs' credit, he also wrote some checks out of his own bank account to keep Pixar going because
he believed in it.
He believed that we'd be able to do a feature film, and he turned out to be right.
Welcome to Beyond the Frames, the media and entertainment industry podcast where I speak to professionals about the art, technology, and business of making entertainment. And today I'm joined by someone who ticks those boxes like no one else in the industry. It's my distinct pleasure to introduce our guest for this episode, the man, the legend, dare I say the icon, and in full disclosure, my dear friend, Mr. Dylan Sisson. How are you, sir?
I'm good. Thank you. Thank you for that nice intro.
Welcome to Beyond the Frames.
Welcome to Pixar.
Thank you. It's great to be here. We're in the Ed Catmull Theatre. Now, Ed is obviously a legendary figure in the industry of computer graphics. This theatre is named after him, and he led Pixar for many, many years. We're going to get into the history of Pixar for sure, and specifically Renderman, which is the group that you work in. But before we get into that, I'd love to talk a little bit about your history, because as I said at the start, you balance the analog art making world with deep knowledge of the CG production world and CG animation, and you maintain your passions in both, but you're also quite forward facing in embracing new technologies like spatial computing and Gen AI. So tell us a little bit about your journey as an artist, and in the early days through to what you do now.
Yeah, that's a
lot.
That's a lot. I don't know where to start. Let's see. I think one of the first times that I really got into animation was when I learned about what it was. Mm-hmm. And I grew up around the Portland, Oregon area, and my mom would take me to the Portland Art Museum when I was, I think, in first grade. We'd see the animated short series, and I thought it was really cool. I think some of the shorts were a little above my head and probably good. I didn't know what they were about, but there's certain shorts like Bambi Meets Godzilla that I remember seeing when I was a kid, and I just thought that was the funniest thing I'd ever seen.
These were indie animated films, right? Indie shorts and indie films.
That was an indie animated film. I think it's ranked as one of the top 50 shorts in the history of animation. Mm-hmm. And after that, I took some classes at the Portland Art Museum and started doing flip books. Mm-hmm. So I was doing flip books in class, like in first and second grade, and just had all these stacks of flip books that just had balls bouncing around. And I really liked the idea of animation. That led me to like playing around with the Super 8 camera, doing stop motion. Mr. Bill was a thing back then. So I built Mr. Bill out of Play-Doh and had some little shorts with his dog Spot and stuff. So that's how I kind of got.
That's how you got inspired?
That's how I got into just kind of the process of animation. But I've always been like making art and drawing and doing stuff like that.
Do you know, the flipbook thing is so interesting. I still feel like that's the most magical part of animation, because you've just been through drawing the simplest thing in a small space, and yet when you flip through it, the joy of just seeing it come alive, something you just put down there from zero, from a blank page.
They're just drawings.
Yeah.
And then you look at them together and you're like, oh, look, it's bouncing around there.
It's the closest thing to alchemy.
Yeah, it's pretty cool. As a kid, I thought that was fantastic.
Mm-hmm,
Yeah.
mm-hmm. So then what about the next milestone, I guess, the CG element of it? So you grew as an artist, you continued to draw. Didn't you work in comics for a bit?
Yeah, in college I had an internship in Seattle at Fantagraphics
Yeah.
Comics, and there I did indie comics, and so I got to work on a bunch of different comics, doing layout in the art department. I worked with Dale Yeager and Pat Moriarty, and learned a lot about that whole process. And at that time, the process was all wax and paste. So we would actually paste. We'd put the artwork through a waxer and put wax on the bottom. Then we'd paste it in there, and then I'd take a photo using a stat machine, and then we'd send it off to the printer. And while I was there during my internship, they brought in the first computers, and everybody working there was super nervous. And they set the computers down. I was like, oh, this is the best thing ever. So I really enjoyed using the computers to make digital art, but I still was learning some of the basic principles. So I studied like lead typography. So I was doing like Vandercook press, like small press stuff when at college as well. Yeah. Bunch of printmaking. And then I got into the computer and I was like, oh, I can do all this stuff and apply a lot of the rules that I learned from these other disciplines into the computer space.
Do you remember what kind of computer it was? Was it a Mac? Was it a...
It was a Mac.
IBM?
It was a, I forget which model it was, but it was...
Was it a colorful one, or was it the old school boxy thing?
It was the old school boxy thing, yeah.
Yeah.
Yeah. So it was pretty... It was pretty neat just to see everybody's reaction to it.
Yeah. And it felt really exciting in those days. This must have been the mid-90s?
Yep.
Yeah, it felt really exciting to bring a computer into the world of drawing and painting to see what you could do next with it. I mean, just the simple idea of reproducing your one-of-a-kind artwork in the digital space and then resizing it and manipulating it, even with... I think I was using Coral Paint then, or Coral Draw, it was Paint, Coral Paint. Didn't have layers, and I was just adjusting colors and creating variations on it. Just that was like a neat trick for me back then in the 90s.
Yeah. It was, I think, 93. And then I remember when we had a little computer convention at the school I went to, and I remember seeing one of the first JPEGs I've ever saw, and I was like, wow, that's full color. It looks like a photograph on a computer. I thought it's amazing. I mean, that makes me sound super old to talk about.
You and me both, yeah.
But, I think it's informative just to think about how fast everything's been evolving, and how the Moore's Law really is driving things in an exponential way, which is actually changing what we can actually do in reality. So technology is actually kind of transforming our reality a little bit. And with these innovations, we can do different things. We can get back to me in a bit, but when they founded Pixar back in 86, Steve purchased the computer lab from Lucasfilm.
Steve Jobs did.
Steve Jobs did, yeah. And their goal was to make a feature film. At that time, they realized that if they were going to make a feature film, it would cost them billions and billions and billions of dollars. And those computers would be obsolete like in a couple years. So they used Moore's Law to figure out when computers would be powerful enough to render a feature film, and they were like, oh, in about 10 years. So they planned to make a feature film by looking at the exponential growth in compute and saying in 10 years we'll be able to do it. I just for fun, I said, well, what if it was linear growth from '86?
Yeah.
They would have been able to render Toy Story in, I think, 2028.
No way.
So the exponential growth in compute is allowing us to do
Whoa.
stuff in a crazy way. And that's how, like, I think Ed was thinking, how Steve was thinking. They realized the massive opportunity that this provided.
Well, on that note, we'll get back to the history in a second of Renderman and Pixar, but that's got me thinking, what if you looked at compute now and charted forward? Have you done that in your mind yet? And like, what would that be? So what would your prediction be? What would your projection be of what we can do in, 5 years?
Well, I think we're actually seeing that with the advent of AI.
Okay.
And like, especially with the Gen AI,
Mm-hmm.
compute is allowing us to create these models that we can use to generate imagery that would have been impossible to compute like 10 years ago.
Mm-hmm.
Even, the first generative AI was making like postage size like images, right? Like in 2015. And so
And quite incoherent, sort of smeary, yeah.
and the growth in compute is actually something that's enabling this technology to be used, and
Mm-hmm.
it's something that's transformed the visual effects industry as well.
Right. Well, okay, so on the subject of transforming the visual effects industry, take me back to his, take me back, I guess, 20, 25, 30 years back, the role of Renderman in sort of changing how visual effects and animation, the standards, raising the standards and establishing itself as like the go-to standard. What do you remember about that time of when it sort of established itself?
Yeah, I mean, I think if you look at Toy Story, rendered in '95, was released in '95. Renderman was established as a RA specification in '88, so and released as a product in '89, and there was formulations of it that were used of renderers that were using the core Ray's algorithm that predate Pixar.
Okay.
So Renderman is actually much older than Toy Story.
Right, and people realize, people don't
And
realize how old it is.
right, and some of the things that were solved that Renderman was created to solve were things like getting rid of aliasing. So we have nice anti-aliasing that came up with stochastic sampling. Things like micropolygons allowed us to not have to render an entire image, so we could render high complexity because it would just render portions of an image at a time. And there was a lot of other things that they did to implement motion blur, depth of field, that were really, really smart and worked within the limitations of the hardware at the time. And the IEEE awarded Renderman for contributions to basically technology that has had a positive impact on human civilization, and particularly in motion pictures.
Yeah.
And this award has been given to Thomas Edison for the light bulb, to the creation of the internet, for the creation of the first transistors, to the Enigma code machine that was
Wow.
used during World War II.
So you're in the company of that kind of stuff.
Yeah, so it's not just visual effects.
Yes.
And also the Texas A&M Speak and Spell. So there's a bunch of cool stuff that that the IEEE has kind of
Awarded,
awarded
recognized.
and recognized. So that was really exciting. And we had last November, we had a bunch of the original architects come and speak about it, and it was really amazing to hear like Ed and Alvy Ray Smith and Tom Porter and Lauren Carpenter and Darren Peachy and Tony Apodaca and Pat Hanrahan. They were all here talking about the early days of computer graphics, and it really drove home that before they came up with the alpha channel, you couldn't do a bunch of stuff. We needed an alpha channel to combine CG with live action.
Or even polygonal modeling, as we know it today, is has its roots in the work that these pioneers did, right? Polygonal
Yeah.
modeling on the computer.
Yeah, absolutely. There's like so many things that they
Catmull
solved.
Clark method.
Subdivision surfaces, yeah. Like all that technology allowed things like in 1989 The Abyss came out. And The Abyss, like, people didn't even know what they were looking at the time. And they were telling a story during the IEEE award where they had created the shading language, the Renderman shading language, RSL, and a complex shader at the time might have been 20 lines of code. They went and check on Lucasfilm and see how they're progressing with The Abyss, and they had a shader that had 500 lines of code, and they had actually written a ray tracer inside of the shader so it could calculate the bounces it needed to make a believable water creature.
Wow.
Yeah, and that is one of the things that I think has always been really, really interesting about the technology, is that being in the Renderman group, we'll make technology, we try and make it as open as possible, and then we're always surprised when people find some new clever way that we never thought about
Of using it.
of using it for some kind of effect.
Yeah.
So that's been, it's never boring.
Listening to that story makes me think about how spoilt we are as artists and creators now, because they didn't have a rich feedback loop like we have now. One of the features that Renderman introduced maybe a year or two ago, it's called XPU, right? And the feedback you get, the richness of it.
Well, we do have an ML denoiser
ML
with the RAS, and that'll be coming to XPU. Yeah.
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 So that kind of feedback loop, they didn't have anything like that. What did they have? They had like very low res previews, and they had to sort of extrapolate from that. Okay, when we do render this on a farm, we think, will look like that, and that's days on the farm.
It was. We are in a privileged place today as far as technology goes, I would say. It used to be you'd press render, you'd go get a cup of coffee, you'd come back and be like, that specular highlight looks pretty good. But at the time, it still seemed like magic.
Of course.
When I was getting started, and I had come from a background of comics, and then I got a job in the CD-ROM industry, which doesn't exist anymore, working on edutainment titles, and learned how to do 2D animation with Macromedia
Director.
Director.
I used that as well.
Yeah, and I could animate really fast with Director, and so that was a lot of fun. And then I got into a job where I was making games for the Sony PlayStation 1, and
Was that 3D games or 2D?
3D games. They were kind of Final Fantasy VII homage or ripoff, depending on how you look at it. But we had a lot of fun with that, and that was a time where I had no 3D experience.
Yeah.
And they hired me based on my animation.
Oh, cool.
And I came in and learned how to animate in 3D. Like, I was reading the books during my lunch hour, being like, oh, this is what an IK handle is. I was like, that's pretty cool. And just learned so much stuff. Learned how to do shading and lighting. I love shading, love lighting. And did some animated shorts. And then opportunity came and I jumped in in the Renderman group. So at the time when I jumped into computer graphics, we didn't have global illumination. So we would simulate reflections, we'd simulate shadows, we'd even for something like fur, until like Renderman came out with deep shadows, you couldn't get fur to look good at all. So because there wasn't any ray tracing.
So then what's Sully in the first Monsters, Inc. made of?
That is an example of the deep shadow technology. So it's a shadow map that would actually accumulate transparency in Z. So it looked like a nice global illuminated shadow, but it was something that we could actually render in production.
I see, and it was a trick that plays to the camera rather than it being a fully formed 3D globally illuminated fur.
It was so we could do localized calculations. So in order to do global illumination, you have to keep everything in memory at the same time.
I see.
It was not possible at the time to do that. So if we calculated a shadow map that had this deep component to it, we could render that locally, and we wouldn't have to rely on doing the bounces during the actual render. And people, saw Sully and was like, "Oh, what a great looking
Furry
character." People weren't like, "Why do you only have one furry character in your movie?" We could only render like one furry guy at the time. Like there's a couple others that have a little fur, but either most of the time they're scales or a leathery or whatnot.
But the creative process, as you know, thrives on limitations, on restrictions. If the brief is do whatever, do anything, it doesn't help the creative process. But if the limit is you can only have one character that's going to be furry, well, then chances are you're building sequences and story around that, taking advantage of that. So would you say that's an example of how this connection between your technical expertise in a studio and the creative artist sort of expertise in the studio kind of go back and forth? Is that an example of the dynamic?
Yeah, I think that's it in a nutshell. When it's working well, that's how things should go. I think creativity, it's counterintuitive, but creativity requires some fences for you to be creative, to have a problem to solve. Otherwise, you could just be doing anything at all. Like even if you look at Toy Story, there's a reason why we made a movie about plastic toys in '95. It's because everything looked like plastic that we rendered, right? But it was also something that everyone could relate to. Like everybody knows what toys are, and all of a sudden we bring that alive, and people are connected to it. So it was a clever solution to the limitations of the time.
Yeah. And what do you think? What do you think the moment was when Renderman wasn't just seen as a tool for animated movies, but something for realistic stuff for the ILM visual effects to what it is now, which is a industry standard sort of high watermark of high quality computer generated imagery? What was the tipping point, and what was the big game changer?
I think if you go back to '88, and you see Renderman came out in '89 as a product. We have The Abyss coming out in '89. We have Jurassic Park coming out in '93, and we had also Beauty and the Beast, which
Yes.
The famous ballroom
The
scene.
chandelier?
The background, that's all rendered. So I think before we got into even the pure animation, there were really amazing things that it was doing on the VFX side, or enabling on the VFX side. And a lot of people don't realize this, but between '88 or from '86 when Pixar was founded and '95 when Toy Story came out, Pixar created about 72 commercials for television for like Listerine, the Listerine bottles going through the jungle, for lifesavers, for gummy lifesavers, and all sorts of things that help keep the lights on. But that also helped us figure out what our pipeline was, and to figure out how to solve some of these problems that were necessary to render a feature film.
Yeah.
And to Steve Jobs' credit, he also wrote some checks out of his own bank account to keep Pixar going, because
he believed in it.
He believed that we'd be able to do a feature film.
Must have seemed like a crazy idea. Like, yeah, you're going to make a feature film with a computer. Never been done before. But that's when you need, I guess, a leap of faith and trust in the people trying to crack this thing. And dreaming. You know, you got to dream a little bit.
Yeah, it was a crazy thing to do. And to make the film and then say, okay, and now we need to find a distributor for the film. Like, it was a tough business to get into. And,
Yeah.
and to their credit, like, they did it. And
Yeah. An entire industry developed out of it.
yeah, whole industry developed out of
Those innovations.
yeah, these innovations. Like the campus here is, you know, a lot of it was built with, you know, some of the windfall from like Finding Nemo. So
Yeah.
it was a testament to the creativity that went into it, but it was also sort of a signal of like, hey, we're going to keep doing great movies like that.
So you as an artist, you've continued to look at new tools, and your Renderman's development is also part of your process. What are some of the things that you're excited about today as a creative, where you're bringing in your analog skill set and your discipline there to combine in a way with your CG stuff and the forward-facing techniques that you've been exploring?
Yeah, I think in my role in the Renderman group, like I've kind of a unique position where I get to kind of kick the tires on new technology that's coming down the pipe, and so I can kind of play around and do whatever I want in my little lab, as long as I'm using the new tech and pushing it in new ways. One of the recent things that we've added to Renderman, in addition to XPU, has been stylized looks. So we can take any type of rendering asset, like polygonal model, and then we can process that in technically what we call a display filter. So it's so when we get the pixels in, we can basically pipe live AOVs or secondary passes into it. Like I can say, I want to take the diffuse pass, I want to do something with that, like create lines, so we could draw lines with it, or do things like create cross hatching, or do tune effects and things like that. So that's been something that I've been playing around with a lot. And for my first test, I had done in 2019 a whole series of drawings by hand on Procreate on the iPad for Inktober. And I developed kind of a style that was based on kind of a, brush pen and a white gel pen.
Yeah, sort of
Copic marker.
black and white ink lines and some of the highlights using a white gel pen, the way you would on paper put some Tipex or whiteout to add highlights, or add that contrast, right?
Yep.
But you did that in Procreate, you said.
I didn't Procreate, but I wanted it to look like something that I could only draw with those tools. I didn't want to have an effect that I couldn't create with those physical pens.
Yeah.
So I had these drawings, and when I got into the stylized looks to test it out, I was like, if I can create this style, which is kind of unique, but also simple enough for me to pull apart. When I created that and recreated that stylized looks, I was like, oh, actually this is really cool. I was working with the developer of stylized looks, Christos Obredenov, who's
from Lollipop Shaders.
Yeah, from Lollipop. And so we were going back and forth, and I'd asked for some feature like line thickness by lighting or something like that. He'd implement it the next day, so it was a real fast kind of R&D process. And the next year comes around, and I'm like, I think I'm going to do this whole month using stylized looks
for Inktober again.
And I thought, well, how am I going to get models every day? And I was like, well, I'll use I had just gotten into VR sculpting. I know that we've talked about this a bunch, and I got into the VR sculpting, and I thought, well, I'm going to try and do one VR sculpt a day and one stylized render of that a day, and see how far I can get through the month. And I got all the way through the month doing one sculpt and stylized render a day.
And you did respond to the actual prompts that were given by Inktober.
Yeah, I did it on the day
Yeah.
of with the prompt.
And that's really only possible with, well, unless you're an amazingly fast 3D modeler with traditional, 2D keyboard and mouse and screen interface. I don't know how else you can achieve that without spatial design tools, right? Because you're capturing your hand gestures. It feels like an extension of drawing to me because I love to draw. And I use VR creative tools all the time to model props and characters in my show. Not because, I don't have the technical knowledge that you have. I use it because no other way lets me realize something as, in final pixel quality than VR tools. But I imagine you're still handy with traditional modeling methods. You've done a bit of that now.
Yeah, I've done modeling.
It's a
I've done
necessity for me, but you...
Yeah. And I've used ZBrush and stuff. I'm not a ZBrush pro, but the VR sculpting, I had the same experience that you did in the fact that it felt like it sped up my modeling process by about 20 times or 30 times.
Yes.
And the thing that I didn't realize when I got into it was that, because kind of like you, like my background isn't sculpting, but I do a lot of illustration, a lot of doodling. I found those skills and that way of thinking translated immediately over into VR. And it wasn't just a matter of being faster, but it allowed me to get a quality to the model that actually was like my hand drawing.
Yeah. Well, it is. It's your hand that's doing it.
Yeah, exactly. Yeah, and so it seemed obvious in hindsight, but I was like, oh, actually, by making a model using this method, all of a sudden it was stylized, and so when I added line work to it or added hatching to it, you couldn't tell the difference.
Yes.
It's harder to tell the difference between the render and actual drawing.
Yeah.
And so that was pretty exciting to me, and I felt like I had unlocked a little prize there, right?
Yes.
Had leveled up.
Little achievement.
Yeah. And so that for me was really informative of kind of that process.
So you do all of that locally on your workstation. Now, a lot of people who watch this podcast love to hear about tech specs and the system that they would want to build or buy that can replicate the workflows or at least offer the kind of same sort of things that we're talking about here. So what do you run this stuff on, and what would you say, what's the range that you would want from a workstation? What's like how scalable is this stuff?
Yeah, the machine that I'm using I bought during the pandemic, and it's RTX, one of the first cards, I think, is it the 1080?
Yeah.
And it's not as good as the machines that are out there today, and
but it's enough for you to do this process.
I can do a lot of that on it, as well as the rendering locally with because I'll bring everything into basically Painter and do the shading there, and then
Substance Painter.
Substance Painter.
Yeah.
Substance Painter, and then I'll bring everything into Maya and render that with Renderman, and using kind of the Renderman shaders and lights, and it has some nice controls for lighting and stuff. So once I get it all in there, my models aren't as complex as a Pixar set. Right?
And they're not as complex as that book you made years ago on that ship.
Right, probably not. So I've learned a few things over the years, yeah. But like I can bring in lights, I can turn them on and off, and I don't really have to wait for things to converge. Things converge pretty much immediately with a lot of this work now with the live rendering. So it's really kind of it's a real fast workflow. And like I was saying a little bit earlier, is that I feel like the technologies are in a place now where I can really get into creative flow and just get an idea in my head and get it out in a really short amount of time.
Yeah, that's fantastic.
Like something that would have taken me a month, now I can do like in a day.
Well, that's amazing. And the iteration cycles, I feel like you still need the same number of passes at an idea or iterations but you can just get through them a lot quicker. You know, it still takes me 10, 15, 20 iterations to go, yeah, that is what I want, but I'm not doing it over 10, 15 days.
Right.
I'm doing it over, half an hour, every half hour I was getting a result, and then I can iterate. Certainly
And
with
if you can
VR,
do it super fast, you can try out all the ideas.
all the ideas.
Yeah. And yeah, that's super fun. And I think even with lighting, now we can move lights around in volumes and
Instant
do
feedback.
get immediate feedback. Whereas, 10 years ago, you'd move a light around and you'd press render. You'd have to be like, what are the controls? How does the volume controls work? And then it would be hard to dial them in. Now you can just slide things around so you get immediate feedback.
In the wider CG community, I often feel like there's a misconception that, because Renderman is a high-end VFX render and it comes from a world-class studio, that it is going to be really demanding on a system, or it's going to be too specific to a studio's workflow and tough to learn. But by the sounds of it, if you're using a 1080 to do some of this stuff, that means it's a very scalable render that it can, it's very accessible.
Yeah, it's super. I think it's very accessible. It's a path tracer, so anyone that's worked with an industry renderer can understand the principles right off the bat. I think one of the things that has always been Renderman's strength is that it's a very open system and it's flexible, and sometimes that can also provide a learning curve a little bit. So to get going with it, I don't think is that actually that difficult, but it is open enough that you have to kind of figure out, like, this is the way to approach this kind of problem, or this is the way to approach
Right.
Another type of problem.
Yeah.
And the I think we're talking a little bit about the Renderman Challenge, and
What is that? Is that a community sort of challenge or program?
exactly, it's something that we rolled out. We just finished our 10th one.
Okay.
And we've been having one or two a year, and it's essentially a challenge to our community. It's something that we've developed where we'll provide a bunch of assets and let users mash up the assets, shade them, light them, and tell a visual story with one image. And people will get into it and spend a lot of time on it. And we thought it would be kind of a fun thing to do. So we have sponsors that sponsor Workstations and things like that.
Oh, cool.
Different software packages, and signed book by Ed Catmull, that sort of thing. But the one thing that surprised me was that it became a platform for people to kind of build their careers. And there's two people at Pixar who credit the challenge with their jobs at Pixar. And there's other people who also credit it with helping them break into the industry in different areas as well.
Oh, fantastic.
So it's a program where we'll actually have mentorship. So if you join the challenge, you can join the challenge community. We do mentorships during the challenge with artists from Pixar, and
Oh, that's amazing.
It's kind of a cool opportunity, and I think in that sense, that's a good way to kind of get into it, because that's what Renderman's for, is visual storytelling. So there's a lot of cool tools in there to help you tell a narrative visually.
Yeah.
And by providing some mentorship, then you're kind of also engaging with the community.
And it's guided, right? It's always helpful to have some kind of guided, structured sort of learning pathway, especially if you're discovering a new tool or getting back into something that's perhaps moved on quite a bit from maybe when you started. You mentioned it's designed for, storytelling. If I think about some of the recent films, Elemental, beautiful film, I love that film, and Inside Out, and Inside Out 2 is coming out later this year at the time of recording. What are some of the things that you think Renderman has been able to do recently that enabled a film like Elemental to be what it is? It's a stunning picture, very unique in that, as the title says, every character is made from one of the elements.
Yep. Yeah, no, that's a good question. I think if we go back to Finding Dory, that is when we basically launched a new renderer for production using the new modern path tracer RAS. So that's the current framework that the renderer is using, and
And that was built from the ground up for that film.
that was built for the ground up for all of Pixar
All Pixar
films
films.
as a new next generation renderer for
Okay.
Pixar. Physically based rendering became a thing, you know, during that decade, and we realized that the hybrid renderer that we had could only be so efficient. So we wrote something that was dedicated to being a very fast, modern, physically based renderer. At the same time, for Finding Dory, we had a project we called Ruckus, and we rolled it out on Blue Umbrella, which was short at the time, and combined Renderman, RAS, first next generation renderer, USD, and Katana, the first time on any production on Blue Umbrella. And we used that, had a little bit of growing pains, but realized that it had a lot of potential. I think out of all the technologies at Pixar, Renderman and USD are kind of the two pillars of that. And Renderman allows us to render a lot of data. It's very open and allows us to really get what we want out of the renderer. USD allows us to create a lot of data, and importantly, it's robust. This is a little plug for the USD. USD's robust, so it's fast. Reading and writing is really fast, but it's also collaborative. So if you think about like maybe layers in Photoshop, you can structure your USD files. So a lighter might be working and lighting on one layer, and a shader might be working on another layer, and somebody's modeling something.
And simultaneously.
And
the
all
same
at the same
file,
time.
Same every department. So I use it all the time. USD, you don't need to sell me on USD.
Okay,
good. I use it for the production of my show, Artina's Art Squad. I love the variance feature of USD as well, where you can have one set of assets, but then you can combine them in different ways, change the materials, but it's still loading and managing that one core asset. So when you've got a scene that's super dense with loads of variations, loads of props and materials, it's a very effective way of making global changes and
Yep.
creating variations. Look at me selling it back to you like
Yeah.
you don't know.
No, that was my next point, which is the non-destructive complexity. So if, you know, like you're saying, if you have a bunch of assets that are all, you know, a theater full of chairs, and the director says, well, how about they look great, but instead of having them all lime green, how about have every other one orange? Easy to do with a variant.
Yeah.
And then the
Or if
director,
one of them, something happened and it's been burnt to a crisp, or some story event happened and one is clearly
swap
a
that
problem.
one out with
Yeah.
something else. Or I think they look great as chairs, but maybe they should be dentist chairs. You know, easy to swap everything
Yeah.
out, and you don't have to reattach a shader per object or bring in a bunch of different geometry and delete other geometry.
Yeah,
You
yeah.
can do it all within that system. So it's a very powerful and flexible system for us to make our movies with, because we could make decisions at the last minute. Katana's very good at allowing the TDs to manipulate USD as well. And so for Finding Dory, we came to a place where we started rendering these really complex, you know, water simulations, because there's fish. And when we were doing that, one of the things that, like, David Ryu said, he's one of the heads at Pixar of tools now. He was like, well, before when we render water, we would do a bunch of cheats to make it look like white foam and do other ways of manipulating water to make it look like water. He's like, we ran a test where we actually had a water simulation, and the TDE actually put in little spheres for water bubbles and rendered that, and it looks like white foam. So basically, we're creating a physical simulation of what light would do, and it looks correct. So we can actually simulate how light behaves. And so that was completely new for the way that Pixar worked, because we had always broken things out into lots of light linking, and we had some global illumination that we were rendering things with, but this really allowed us to take it to another level.
So previously it gave the impression of volumetric water and deep sea. I remember some of the tests on the DVD extras on Finding Nemo, and what that looked like. It looked very convincing to me, but it was, compared to simulation, it was essentially faking it.
There was a lot of cheats, yeah. And so now we could actually simulate all that cool stuff. And so we fast forward to Elemental, same RAS technology that we're using, and the water simulation of like the dam bursting and all that good, all the real world water, all that stuff looks very realistic.
Yeah.
But the characters, they're stylized. So, Ember, she's stylized fire. Wade, he's stylized water. And even though they're stylized, they're still grounded in kind of this physically based reality. So Elemental, I think, was maybe a milestone for us, because it was a movie that we couldn't have rendered like 3 years before, just because it was so complex, because the characters themselves were volumetric simulations. Like Ember's actually a fire simulation created in Houdini, and
But working with the animator's input, because you can't simulate the character's performance. That's the animator doing it, right?
yeah. So it was something where the technical team got together with the creative team. The creative team was like, look at this concept art, and the technical team's like, oh no. And
Well, earlier we said the creative process needs limits.
Right.
And, so the technical team needs challenges, I guess.
Right. So they rose to the challenge, and we actually figured out ways of creating, fire simulations that we could animate, and they would behave like fire when the characters would move their arms. They would detach from the body, kind of like a flame. But we were actually doing very expensive computational calculations when we were rendering these characters. And, there's certain scenes where you can see Ember walk into a room, and she's actually illuminates the entire room, because she's actually a light source.
So Ember is made of fire. She's illuminating the scene, and there's all the environment, props and stuff around, all the materials and the lights in the scene as well. And then Wade is refracting and reflecting all her light as well.
Yeah.
So that's very demanding for the renderer, surely.
Yeah, it's a very complex problem to solve. So we actually expanded our render farm to actually be able to render Elemental. So we grew it up to 150,000 processors. So we had the latest processors from AMD, upgraded the entire render farm to 150,000 processors, and we're able to render Elemental. But it was a significant challenge.
I bet. But everyone rolled their sleeves up and like, oh, we'll take it on, just like Pixar always has risen to the challenge, both on the creative side and the technical and story.
Yep, and there's so many elements that go into something like this. Like we also have like denoising technology, which we've had Denoiser since Finding Dory. It's important to kind of to resolve the kind of the artifacts that path tracing creates until you approach full convergence. So instead of rendering to like 4,000 samples per pixel.
Yeah.
We can render to an average of like 64 samples per
Oh,
pixel
wow.
now.
But that's not for final delivery, presumably, or is
Yep,
it for final?
that's
Really?
for final delivery.
Oh, cool.
And when we rolled it out for Finding Dory, it was it was our first take on Denoiser. But for Toy Story 4, we took a new denoiser that was developed at Disney Research, which was based on machine learning and had been trained on a bunch of data from the Disney company, from
Right.
different studios. And that allowed us to drop our render time significantly because it was so good. And so when we combined the new machine learning denoiser with rendering the volume simulations in Elemental with the advances in Renderman with RAS, we were able to do something that we weren't able to do before, which is a fun part of visual effects. It's not just about making things faster, but making new images and new kinds of stories that people haven't seen.
Yeah, realizing a vision that maybe someone had for 10 years that would have been impossible to realize and execute in that way until the innovations, these various innovations come together and are combined by the people who are figuring this stuff out. So on the denoiser side of things, is that a feature that comes with Renderman for anyone to use now?
We don't use any kind of Gen AI at Pixar.
Okay.
But our machine learning denoiser is like a narrow use case of AI. And so that's specifically trained to do denoising, and it ships with Renderman. It's a non-commercial Renderman, so anyone can use it. And it's very good. And we'll be in the next version of Renderman, which should be coming out in a week or so. It will have an interactive denoiser, which is based on the same machine learning technology.
Right.
And so that'll allow people to start rendering their images and then immediately get a fairly converged image right off the bat.
I see. Oh, that's handy.
Yeah.
Yeah, so much more immediate feedback. Does the ML denoiser and that kind of approach, is it still relevant for more stylized work? Like if I think about Inside Out and how, some of the characters have like a crayon-y sort of effect to their edges, or when they go into different modes of different styles of rendering in the movie.
Yeah, I think for Inside Out 2, we wanted to create the similar look from Inside Out, but Inside Out was rendered with the older Raise
previous-
renderer.
Yeah.
And the new one is rendered with RES renderer. So we had to find ways to render those types of effects using the physically based renderer that we have now.
Yeah.
Because it's not as easy to break it and do arbitrary things with the shading language.
Yeah.
So that is something that is going to be interesting for everyone to see, like how that looks and where we've taken the look for Inside Out 2.
You mentioned stylized looks before, and how stylized looks are something that you're actively sort of exploring and developing for Renderman. Do you remind me about the process again? Is it manipulating a PBR sort of foundation to make it look stylized, or is it a completely new thing in and of itself? Because you mentioned you take the albedo map and you do stuff with it. That's still the PBR pipeline, right?
Right. So we have the physically based pipeline. So the denoiser is going to take any of that stuff and denoise it. For the new Renderman stylized looks that we're calling it, the process is that Renderman can render out a host of AOVs, arbitrary output variables, or LPEs, light path expressions, and we can take any of those channels, arbitrary, it could be, but let's say it's diffuse or it's specular, we can plug that into what we call a display filter, and that basically allows us to just say, hey, I want to create a tune look, or I want to create a line look, or I want to create a hatching look, and I want to use this signal to drive that. And so the stylized looks is a system that's interactive, so you don't have to go to Nuke or to a compositor to see the final result. You can see the final pixels live when you're looking at it, or you can continue to take that into your compositing workflows. And right now, we could have a denoising solution for that at some point, but it's a slightly different path. So it's a way of breaking the physically based renderer within
Got it. Yeah.
the physically based renderer.
Yeah.
Yeah.
Yeah. Cool. Well, these are techniques and exciting features to explore. In my show, I have the show is set in a junior school classroom, and it looks sort of realistic, slightly stylized, but quite PBR based, quite realistic setting. And I do that because the main character travels into artworks to meet artists of oil painters and watercolors or whatever. She travels into those worlds, and when she does, the whole style changes to the look of that particular artist's style or that painting. So I needed to contrast it, right? So that's where something like real-time ray tracing and PBR sort of rendering methods are critical to setting the normal world so that it's all the more impactful when you go into stylized worlds. What should I do if I want to explore stylized worlds with Renderman? What's the, and this is for anyone looking to explore these new features, what do you think the starting point is? Understand the foundation of PBR and then go into it, or just jump in and start playing around and look at the ground truth that you had in your artwork as a reference and try to replicate that? What's the right pathway?
Right. Like I think for me the first thing is just the concept art, because if you look at physically based rendering, there's a ground truth, and that ground truth is what light would do.
Yeah.
And if you look at an image or render and you say light's not behaving the way it should,
Yeah.
either that's on purpose for an artistic result, or it's a bug, or user pilot error or something.
Yeah.
And if you look at something like Elemental, the characters are very stylized, but
Yeah.
they're rendered within the confines of a physically based renderer.
Yeah.
So I would suggest starting with your ground truth for stylization, which is the concept art, and then picking that apart and backing up and saying,
How would I replicate this in
how
3D?
do I, what are the elements that make this stylized? It could be the modeling. Maybe you need to start with the models in your scene. Maybe it's not just the final rendering. And, with the work I did with Inktober, the models I created were stylized enough that when I added the stylization in the rendering, they looked pretty convincing.
Yeah.
So when you start picking apart whatever kind of artwork that you want to travel into, figure out what the rules are, and then figure out, where can I put this stylization in the process?
Yeah, fantastic. Well, that's a good tip that I'm certainly going to take away for my production. And this episode was full of stuff. I told you this guy, he walks the line expertly between the business of entertainment, the technical elements that go into animation, and the artistic process, of course. So if you love this podcast, give it a like. Leave a comment, and if you want to get in touch with Dylan, you can find him, LinkedIn and Instagram. Just look for Dylan Sisson. You'll find him. He's a legend in the industry. It's not hard to find him on Google for sure. And if you like this episode, just let us know in the comments. And for more of this stuff, check out Scan Pro Video, who produced this episode and all the other episodes that we've done so far. I'm your host, Rafi Nizam. This has been Dylan Sisson, and we're here at Pixar. And thank you very much for your time.
Yeah, thank you.
All right, dude.
Yep. Cheers.